continuing, I now want to illustrate the idea that we can see we can present people different sets of choices and perhaps see behavior that looks to be violating, well, either violating transitivity or violating transitivity if we assume also monotonicity. Okay, so this relates a bit to the idea of these axioms of revealed preference I mentioned. The weak axiom of revealed preference simply says that if I give someone A and B and they choose A, then if I give it to them, if I give them A and B again, they also have to choose A. Okay, because when they choose A here, we say A revealed preferred to B. So it shouldn't be that, and then we have that it shouldn't be that B revealed preferred to A. But this doesn't seem to deal well, at least as I see it, with indifference. Right? It could be maybe they're just indifferent between the two. Okay? We could also imagine presenting them sets of choices and looking for strict violations where they have the apple and the banana, and they choose the apple, suggesting they prefer apples to bananas if they're choosing the thing that's in line with their preference. Banana and the cherry, suppose they choose the banana. Cherry and the apple, suppose they choose the cherry. This would seem to violate transitivity. But if we allow for this monotonicity, there's subtler sorts of violations we can look for. Okay, so we can imagine giving them, okay, and this could be in real world data. We might observe their actual income and prices and consumption, or some sort of framed experiment. If we look at the Choi experiment, they actually make these two goods basically just payoffs that occur in different states of the world. If there's the heads, they get X amount. If there's the tails, they get Y amount. And each combination represents some amount they get in either state of the world. Okay, so let's imagine that they are presented with this blue budget set. I'm not even going to label it, it's just the blue budget set. If they choose this point here on the blue budget set, or let's say they choose this point here on the blue budget set, okay? And we've discussed in the last bit about what that tells us about their that this is essentially, if we have monotonicity, or sorry, nonsatiation, this must be at least as good as any of these points and strictly better than points strictly below. Okay, now suppose we give them another budget set, the red budget set. You see, there's some things available in the red budget set that aren't available in the blue budget set. Right? In the red budget set, they can choose these guys, blue not. In the blue budget set, they could choose these guys, red not. Okay, so suppose they chose point A in the blue budget set. When they were faced with the blue budget set, they chose point A. Okay, and now suppose when they're faced with the red budget set, so they could choose anything on or below the red budget line, suppose they chose point B. Okay, this particular set of choices would seem to suggest a violation of having a consistent set of preferences, and in other words, a set of preferences that do not change. That's what I mean by consistent. And also the more is better axiom. One of any of the more is better axioms, in fact, that we talked about. Okay, so why is that? Okay, so if they chose point A when they faced the blue budget set, that suggests that they found point A at least as good as any other point they could have chosen, such as point B prime. They could have chosen B prime, they chose A. So that means that if they were following their preferences, we know that A is weakly preferred, i.e. at least as good as B prime, at least as good as B prime. And with monotonicity, we have that B prime must strictly be better than B. So monotonicity suggests that B prime is strictly preferred to B. Putting these together with the way, the sort of transitivity these has, so this will this one will dominate, as you can imagine. It's intuitive. So we say A weakly preferred to B prime, which is strictly preferred to B, therefore A is strictly preferred to B. All right, so these are the preferences that were suggested by their choices when they had the blue budget set. Okay, what about when they had the red budget set? They chose B, okay? That suggests that B, that point B, this point here, what they could have chosen this point, let's call it A prime. Okay, let me just move this so it's clear. So this is point A, the point down here. This is point A prime. They could have chosen A prime, but they didn't. They chose B. Okay, so that means that according to the choices they made, if they were being consistent behavior, that is behavior that chose the thing that was preferred when both were available, that would tell me that B is at least as good as A prime. And by the same monotonicity argument, look, A prime has more of both than A, so we have A prime must be preferred to A. Therefore, putting these together, B preferred to A is suggested by their choices under the red budget set. Okay, so we see there's no set of this suggests a violation of transitivity. A being preferred to B and B being preferred to A, that's a violation of transitivity. So there's no set of preferences that do not violate transitivity joined with the more is better that would justify this behavior. Okay, maybe the word is rationalize this behavior. Okay, the next question you might want to know is, okay, do people make these choices? Well, they seem to. As I said, you can look at supermarket, or you can look at consumer data, you can look at experimental data. People do make these mistakes, but you might want to have some measure of how much they make these mistakes. Not just how many times these make these mistakes, but how significant are these mistakes? And who make these mistakes more often, and under what conditions? Let's put mistakes in quotes, okay? I don't want to be judgmental. So one way of thinking about it is, all right, well, suppose that instead of choosing A under the blue budget, instead of choosing, what did I just say? B under the blue budget constraint, instead of choosing A under the blue budget constraint and choosing B under the red budget constraint, which we say they did, suppose they had reversed it. Let's say they had chosen A under the red budget constraint, which would have been something strictly inside of their budget set, and they had chosen B under the blue budget constraint. Again, something strictly inside, strictly cheaper than their budget set. We can think about how much income would have been saved in some sense, right? How much would we been able to push this in and still have them be just as well off? Another way of thinking about it could be, all right, if they had made that reversal, but suppose then we say they made that reversal, they chose A under the red budget set, right? They actually could have, let's think how much more could they have consumed of, let's say, one of the goods. They could have consumed this amount more of that good, and if they had chosen B under the blue budget set, they could have consumed this amount more. Okay, so we can think about how much these things could have been shifted in some sense. And those are the sorts of questions, that's sort of like the way that the Choi is measuring it, but it gets a bit more complicated, and he's looking at generalized axiom of revealed preferences, which involves looking at multiple budget sets and what they imply for these. Okay, I hope that's helpful.